Let's examine the motion of an electric charge in a uniform magnetic field. Because the magnetic force depends upon the cross product of the charge velocity and the magnetic field, the motion is usually three-dimensional. We will start with the special case where the initial motion is perpendicular to the magnetic field. In this case, the resulting motion will be confined to a plane perpendicular to the field. Since the force, and hence the acceleration, is always perpendicular to the velocity of the charge, the resulting motion of the charge will be circular. The force on a negative charge will be in the opposite direction. Positive and negative charges will traverse their circles in opposite directions. Speed also affects the radius of the circular motion. However, the time it takes is not affected by the speed. The frequency of the orbits only depends upon the charge, the magnetic field strength, and the charge's mass. Returning to the more general 3D case, the net motion of the charges will be determined by the parallel and perpendicular components of the charge velocity relative to the magnetic field. The component of velocity parallel to the magnetic field determines the part of the motion along the magnetic field lines. The component of velocity perpendicular to the magnetic field determines the circular motion around the magnetic field lines. The net result is helical motion, where the charges spiral around the magnetic field lines.